In the okay, we had stopped at oceanography. We had to start with oceanography, correct? Right? Let's start with ocean. Okay, everybody's ready?
ಸರ್ ಸ್ವಲ್ಪ ಕ್ಯಾಮ್ರಾ ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಬೋರ್ಡ್ ನಿಮ್ದು.
ಕೋಡ್ ಕಂಪ್ಲೀಟ್ ಬರೋದಿಲ್ಲ ಅನ್ಸುತ್ತೆ.
ಬರುತ್ತೆ ಸರ್.
Fine.
Yeah. ಸಾಕು ಸರ್.
Okay, before that, highest amount of water is what is the highest source of water? It's the ocean. Then you have to arrange in order. Then 97.25% of water is in ocean, right? Next ಯಾವುದು? Rivers, glaciers, ice and glaciers, right? So in the form of ice. Next, third one should be groundwater. You should know this order. Yes. Next, lakes. Next, soil moisture or atmosphere? Soil moisture. Next, still confuse ಆಗುತ್ತೆ ನೋಡಿ. Soil moisture and atmosphere ನಡುವೆ confuse ಆಗುತ್ತೆ. Atmosphere. Next, streams and rivers. And last, biosphere. Right? No need to write it. All of this has been given in NCERT itself. Okay, just go through it. So you'll get confused. You think rivers have more water than lakes. So be sure that lakes have more water. Then here also you'll get confused. Soil moisture and atmosphere. So be mindful of this. So we have to start with ocean relief features. Earth is called blue planet because it has more amount of water, right? What's the total percentage of water? More than 71%, right? The remaining 29% is land. So that's why Earth is called blue planet. There is another planet which is called by the same name, blue planet. What is that? Huh? Uranus or Neptune? What is that? Uranus or Neptune? And why? It's Neptune. Why? Why? It contains methane. You know, gaseous planets ಅಂತ ಹೇಳಿದ್ನಲ್ಲ, jovial planets ಅಂತ ಹೇಳಿದ್ನಲ್ಲ. So last 4 planets. So in that first 2 planets, Jupiter and Saturn have hydrogen and helium, whereas Uranus and Neptune have methane. Okay, so methane, it reflects blue color. That's why they appear blue in color. So Earth is also called blue planet because the reason is different here. What is the reason here? Because of presence of water. Okay, hydrological cycle. You know everybody hydrological cycle. Everybody know about the hydrological cycle. Tell me what is, from where we should start. So start from precipitation, right? Precipitation. Once it will be falling in the form of rainfall. Part of it will be in the form of runoff water. Runoff water. Just tell me the components. Next, circulation. Right. Yeah. Next, underground water. Underground water. Yes. This underground water can be part of a, can become a part of a stream or a river. Right. Stream will turn into ocean. Ocean. All of that. Then there are trees and water bodies. Then evaporation and transpiration. All of you know this process, right? Okay. We study mainly. We start with this divisions of ocean floors, ocean reliefs, right? So tell me from first to from the, we will start from the land part here. Okay, continental part. From that, the first division would be what? Continental shelf. After that, slope. Then
Plain.
rise. Then there can be trenches, and there can be abyssal plain. Correct? Abyssal plain. So these three are continental shelf, slope, and rise. These three are part of continental plate. These are part of continental plate. Correct? They are part of continental plate. Right or wrong? Right. So every continent, take African continent, right? African continent, for example. So next to this, till here, there might be these three divisions: shelf, slope, and rise. So they are continuation of continental plate. Correct? Understanding this? Okay. So shelf, slope, rise, and what is this? Last part is abyssal plate. Right. So in the mid ocean, there can be ridges. There can be ridges and rift. Correct? Rift and ridges. Okay. So now tell me, these ridges are features of what type of plate boundary? Divergent plate boundary. So this is part of divergent plate boundary. So there is a plate boundary here. That is why ridges are formed there. Correct? So there is a trench here. What does it mean? Convergent plate boundary. This is feature. There is a boundary here. From here, oceanic plate is starting. Okay. From here, this side, continental plate is starting. That's why these are part of continental plate. Shelf, slope, and rise. And these are oceanic plates, right? So within there can be two oceanic plates, right? This is another oceanic plate, this is second oceanic plate, and this is continental. All of this is continental. So where there is a divergent plate boundary, there can be ridges. Right? So one famous example for this, Mid-Atlantic ridge, that is the longest ridge on Earth. Right? And remember, longest this mountain series on Earth are not on land; they're in oceans, and these are the ridges. Okay, so there is a continuous ridge which are connected in every ocean. Right? So let's discuss about shelf a little bit. What is shelf? It is the first part of in the ocean floor, right? It is attached to the landmass, right? So its variation is less. So the degree of variation is slope. Variation of the slope is less than 1 degree. Less than 1 degree. And here the variation is between 2 degree to 5 degree for slope. Correct? So that's why its depth is also less. Its depth is also less. So and the width of this also varies. Sometimes it can be as long as 1,500 kilometers in Arctic Ocean, like Russia, for example. Remember this fact that the Arctic coast of Russia, okay, that has longest continental shelf in the world. Arctic northern part, Arctic coast of Russia, that has longest continental shelf. Whereas the shortest one you would see where in the South American coast. South American coast has shortest shelves. There some at times it is absent completely. The shelf part is absent in few places, and wherever it is present, its width is very less. Okay, and there is a continental slope, and you know that continental shelf and slope is the place where deltas are formed. River deltas are formed in these places, like Ganga Delta, Godavari Delta, Krishna Delta. All of them are formed in the continental shelf and slope part. Why? Because rivers, when they join the oceans, they deposit all the sediments here, forming the features of delta. Everybody know that, right? Delta andre ಗೊತ್ತಲ್ವಾ ಎಲ್ರಿಗೂ introduction ಇದೆ ಅಲ್ವಾ? Yes. And slope here is the depth is, it can be up to 3 kilometer, starting from around 500 meters, right? So it's as deep as 3 kilometers. The deepest slope should be 3 kilometer deep. And next, this is abyssal plain. So these are deeper parts of the ocean, which is a plain. And before that, trenches are the landforms created at what type of boundaries? Convergent plate bond. That is that a trench is formed here. Right? Why there is a trench? Because two plates, there is one plate subducting inside another plate. That is why it has created a depression here or a deep here. This is called trench. Correct? So highest number of trenches you can find in Pacific Ocean. Okay. So Pacific Ocean has found where we have observed highest number of trenches. So these are deepest parts of the earth, like Mariana Trench. All of you might have heard, right? That is the deepest part. It's in the Pacific Ocean. Correct. Next, abyssal plain can have some mountains also if there is volcanic eruption here. Consider there is a hotspot activity going on. Correct? Like take the example of Hawaiian Islands. Where are they? Hawaii Islands have oceans. Hawaii Islands are one of the states of USA. They are located in Pacific Ocean. This is the 50th state, right? So these islands are formed due to volcanic eruptions. Okay, so these are volcanic mountains actually. When volcanic mountain comes above the water, that forms an island, right? So like that. Imagine there is an volcanic activity going on. This is the volcanic hotspot, or you can say magma chamber here. It is erupting what? This lava or magma. It is creating what? Seamount. What is this called? A mountain inside the water is called seamount. Always remember. A mountain inside the water is called, inside the ocean is called seamount, right? And, metamorphosis? I mean, not where? Here. Plate boundaries. It can be anywhere. Here also they can undergo. Because there is subduction zone, right? So above there is water. It doesn't make difference. So these underwater mountains are called seamounts, and seamounts have pointed peaks, right around, just like our Mount Everest. They have pointed peaks. Sometimes these seamounts can be like, these mountains can have flat tops instead of a pointed peak. Correct? So these kind of structures are called fjords. They are called fjords. So what is the difference between fjords and seamounts? Both are underwater. First of all, similarity is that both are mountains, but the difference is that seamount has pointed peaks, whereas fjords have flat bases. Correct? If the same mountain comes above the surface, what happens? This will become an island. Correct? So this is how many islands have formed in Hawaii, right? So where there are what kind of volcanoes? Shield volcanoes. Always remember Hawaii volcanoes are famous example for shield. One famous example for seamount there is Emperor Seamount. Emperor Seamount, that is inside the water in Hawaii. Within the Hawaii island chain, there is one seamount which is underwater. That's the most famous seamount of the world. That's located in Hawaii Islands. What is the name of that seamount? Emperor. Okay. Apart from this, within the same Hawaii Islands, there are some mountains which are the tallest in the world. If you consider from base to the peak, if they measure, they are tallest. They are around 10 kilometers. Tell me two of them. Mauna Kea, and next to that there is Mauna Loa. Okay, so you can go and check all of these in maps, or you can search for it. Okay, so these are tallest in the world if you consider from base to the top. Single-handedly to consider. Not above sea level, they are 4 kilometers. Above sea level, 4 kilometers. Below, there are another 5 kilometers. Mount Everest is above sea level, 8,800. But these are, if you measure it from base to top, they are taller than Mount Everest. Okay. So these are the features. All of you have studied. All of you understood the ocean floor. Ocean floor component. So rise means nothing. Don't worry. It is rise ಅಂದ್ರೆ continental shelf ಇದೆ, slope ಇದೆ. Rise is actually, it's not like rise. Actually, here the rate of decrease increases. I mean, the rate of decrease in the slope, right? That it will be very steeper here, right? At certain point, it can be even flat, but still it is called rise because the rate of increase in the depth here decreases. Okay, after that there can be trenches or plains will start. So this transition place where this decreasing depth will stop, that is called a rise. Okay, that's a very narrow division, so don't worry much. But consider that that is also part of continent. Okay. So atolls. Another thing is atolls that we have to discuss. What is an atoll? Atoll means it's a coral reef. Everybody have the knowledge of corals, right? So coral deposition, when corals secrete, this calcium carbonate, that will build this reef. Reef anta karidೀವಿ. That structure is called reef, right? Which is nothing but secretion of limestone. Limestone structure, right? So that is built by corals, right? So when there is a mountain, already we have discussed how mountain forms due to volcanic eruption, right? So there is an island has formed, right? So along the island there will be fringing or barrier reefs will be developing around this. See here, there is a reef has developed, and if you consider all the sides surrounding this island, reef structure has been built. Correct? Built by corals. Corals always develop near to the coastline. All of you know that the continental shelf and continental slope region where there is shallow water, depth is not more, so they receive sunlight and they survive and they secrete calcium carbonate and they build the reef, right? So these coral reefs are built around the island. Once there is an island, around that island coral reefs are built, so which is circular more or less because island is circular, correct? So what happens eventually, this middle, that is island, can get inside the water for various reasons, due to subsidence or due to erosion. For whatever reason, the island itself has went below the water, but the coral reef still it is there, surrounding that ring is still there, right? Okay. So now the island earlier, which used to be above water, now it has become a gyot-like structure. This can be called a gyot, right? With a flat base. Now it has become a gyot. But the island, this is still up. This coral reef is still above the water, right? So such islands are called atolls. Such islands are called atolls. So famous example for atolls is our Lakshadweep Islands. So Lakshadweeps are formed like this. Lakshadweep Islands are atolls. Always remember. And Maldives, for example, they are also atolls, right? So next we'll discuss distribution of temperature and salinity. I'll simply guide you how to tell me what are the factors which affect the distribution of temperature and salinity in ocean. Really? What factors determine the temperature in the ocean at a particular place? Latitude is the first. Okay. Factor. Latitude. Okay. Distribution of land and water. Okay. Distribution of land and water. Next, currents, winds. So yeah, rivers you can write a separate point, or else you can include begins. Let's write separate point. The fresh water supply, right? Mainly, it can be rainfall or it can be rainwater, river water. So, so we can say fresh water supply. I mean, availability of or fresh water supply is another factor we can write. Yeah. So let us discuss one by one quickly in one or two words. Tell me latitude, how it depends. So with increasing latitude, what happens with respect to the sun? Temperature? Huh? Temperature? Temperature decreases. With increasing latitude, temperature decreases. So that's why higher latitude seas and oceans have lower temperature compared to the uh, lower temperature compared to the water bodies of lower latitudes, right? Uh, okay. So this is easier. Distribution of land and water. Give me some example for this. So yeah, compare northern hemisphere and southern hemisphere. In northern hemisphere, there is more land, right or wrong? Northern hemisphere more land. So generally, water bodies of northern hemisphere are more have higher temperature compared to the water bodies of lower. Generally, okay. So that's another factor. And one more factor with respect to this is one more explanation for this would be with respect to the landlocked water bodies which are surrounded by land, at least on three sides. So for this to understand, we take two examples. Number one, Red Sea, and another one, Baltic Sea. We compare both of them. Okay. So where is Baltic Sea? All of you know, it's in Norway, right? Europe, Norway, higher latitude near Arctic Circle, right or wrong? Okay. So there is this Arabian Peninsula, Africa, right? So this is Red Sea, Red Sea. So we'll compare this to uh, Baltic Sea is here, even at higher latitude than this. What I'm showing. So this is Baltic Sea. So Baltic Sea is near Arctic Circle. So in terms of latitude, it is at higher latitude. So temperature is less, right? So this surrounding land here is hot because it's in subtropical zone, almost at subtropical zone, right or wrong? In subtropical zone, there is highest temperature on Earth. Subtropical zone. Many deserts, for example, Sahara is located here. This Saudi Arabian is also desert. So it's surrounded by hot landmass, right? So that's why the Red Sea temperature is also higher. Correct. So distribution of land and water. For that, you can write this example. So Red Sea is surrounded by land body, which is hotter. That's why Red Sea is also hot. Temperature is high. Take the example of Baltic Sea. Baltic Sea is at higher latitude, right? It is surrounded by land, but this land itself is cooler because land is in higher latitude. Correct? Arctic Circle only land has lower temperature. Correct. So when land itself is cooler, the water body is also cooler. So that's why in Baltic Sea the temperature is lower. Correct? So this is how it affects. And ocean currents. So currents are gota. All of you know I have the basics of currents. Okay. So how current affects? For this one famous example, I should always write in exam. Okay. Again, there is this Norway, right? Norway is Baltic Sea, Norway. So here, USA, this side. From USA, an ocean current is uh, flowing, right? What is this? Gulf Stream. Gulf Stream, and this will become North Atlantic Drift, right? And when this will arrive here, it is called what is that? What is it called? Norwegian Sea, Norwegian current, Norwegian current. Okay, same Gulf Stream and North Atlantic Drift. So this current brings hot water from lower latitude to higher latitudes. This is near Arctic Circle. The water should be cooler here, right or wrong? Logically, it should be cooler because it's located near the Arctic Circle. But still, it has warm water. The reason is this current. This current brings water from lower latitudes, which is warm water, to this side. Understanding this? So ocean current is also determining temperature. Correct? And you know that everywhere in the lower latitudes, any continent, for example, take Africa, western coast has always cold water, cold due to cold current, and eastern coast have warm water because of warm current. Okay, then Peruta. So ocean currents are also determining the temperature of any ocean body, right? Next, winds. For winds, one explanation you can always give. Consider this is a land, like take America and Australia and South America. Wind, how it affects. This is South America and this is Australia. If winds are blowing from here to here, okay, so here they are called land breeze because they're coming from land. Here they can be called sea breeze because they are coming from ocean to the land. Everybody is clear with this? So wherever the place where land breezes are dominant, okay. So what happens? Land breezes are dominant. The water from coast will be displaced to the other side. And the water from here will be displaced to the other side. Now there is a deficit of water this side. Why? Because wind has carried the water from here to here. Everybody is agreeing with me for this? Now there is deficit of water. To fill this deficit, water from deeper levels will come to the surface. This is called upwelling. What is this called? Upwelling, correct? So upwelling means water is coming from deeper parts of the ocean. In the deeper parts, there is cold water. Cold water is coming to the surface. Now here, temperature will be less because this is dominated by cold water. Right or wrong? So if there is a domination of land breeze, at such places you'll find cold water because the water has been displaced. To replace that cold water has from bottom has come to the top. Understanding this? Now the water is getting accumulated here. If there is more accumulation, what happens? The weight increases, so water has to go down because disconnect either. Okay. So shall I continue? Online error once confirm ಮಾಡಿ.
ಸರ್ ಸ್ಕ್ರೀನ್ ಶೇರ್ ಆಗಿಲ್ಲ ಅನ್ಸುತ್ತೆ.
ಶೇರ್ ಆಗಿಲ್ವಾ ಇವಾಗ? ಶೇರ್ ಮಾಡಿದ್ನಲ್ಲ
ಇಲ್ಲ ಸರ್.
ಬರ್ತೀನಿ. ಓ ಮತ್ತೆ ವೈಫೈ ಇಶ್ಯೂಸ್ ಇಂಟರ್ನೆಟ್ ಇಶ್ಯೂ. ಹಾ ಹೇಳಿ. ಅರ್ಥ ಆಯ್ತಾ ಅದು? ಅಪ್ವೆಲ್ಲಿಂಗ್ ಡೌನ್ ವೆಲ್ಲಿಂಗ್ ಎಲ್ಲ ಆಗುತ್ತೆ ಆನ್ ದಿ ಅದರ್ ಸೈಡ್. ವಾಟರ್ ಒಂದ್ ಕಡೆ ಈ ಕಡೆ ಅಕ್ಯುಮುಲೇಟ್ ಆಗ್ತಾ ಇದೆ ಆಸ್ಟ್ರೇಲಿಯನ್ ಸೈಡ್. ಸೊ ವಾಟರ್ ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ ಕೆಳಗೆ ಹೋಗುತ್ತೆ. ರೈಟ್, ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಡೌನ್ ವೆಲ್ಲಿಂಗ್. ಸೊ ಡೌನ್ ವೆಲ್ಲಿಂಗ್ ಆಗ್ಬೇಕಾದ್ರೆ ಏನಾಗ್ತಿದೆ ಅಲ್ಲಿ ವಾರ್ಮ್ ವಾಟರ್ ಮತ್ತಿಷ್ಟು ಆ ಕಡೆ ಈ ಕಡೆ ಬರುತ್ತೆ. ಸೊ ಆನ್ ದಿಸ್ ಸೈಡ್ ವಾರ್ಮ್ ವಾಟರ್ ಕಲೆಕ್ಷನ್ ಆಗಿರುತ್ತೆ. ಸೊ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆಗಿರುತ್ತೆ. ಸೊ ವಿಂಡ್ ಇಸ್ ಆಲ್ಸೋ ಅಫೆಕ್ಟಿಂಗ್ ಟೆಂಪರೇಚರ್, ರೈಟ್ ಆರ್? You can take the same example of North Atlantic drift. Just now the current is going to Norwegian pole. That is also a result of wind. Wind is generating that current. Wind is responsible for the current. So indirectly, wind is also responsible over there. So here what happens? More water online ಕೇಳಿಸಿದ್ಯಾ? Screen share ಆಗಿದೆ ಅಲ್ವಾ? Somebody please confirm.
Sir,
No, sir.
explain.
No, sir.
Actually, boards share ಆಗಿಲ್ಲ, ನಿಮ್ದು ಇದಾಗಿಲ್ಲ.
ಬೋರ್ಡ್ ಶೇರ್ ಆಗಿಲ್ವಾ ಸ್ಕ್ರೀನ್? ಮತ್ತೆ ಡಿಸ್ಕನೆಕ್ಟ್.
ಬಟ್ ಕಾಣಿಸ್ತಿದೆ, ನೀವು ಕಾಣಿಸ್ತಾ ಇದ್ದೀರಾ. ಸೊ ಯು ಕ್ಯಾನ್
ಹೌದಾ?
ಎಕ್ಸ್ಪ್ಲೇನ್ ಸರ್.
ಅದು ಮತ್ತೆ ಇಂಟರ್ನೆಟ್ ಸ್ವಲ್ಪ ಇಶ್ಯೂ ಆಗಿದೆ, ವೇಟ್ ಮಾಡಿ ಪ್ಲೀಸ್. ಲೈವ್ ಕಂಟಿನ್ಯೂ ಇರುತ್ತೆ. ಆನ್ಲೈನ್ ಇರೋರಿಗೆ ಸ್ಕ್ರೀನ್ ಶೇರ್ what happens to temperature with increasing depth? Huh? salinity increase. Pakka. So it increases or decreases ಅಂತ ಕೊಟ್ರೆ ಏನು ಬರೀತೀರಾ? Salinity increases, but the rate of increase will change. ಓಕೆ, ಆನ್ಲೈನ್ ಇರೋರಿಗೆಲ್ಲ ಪರ್ಫೆಕ್ಟ್ ಆಗಿದೆ ಅಲ್ವಾ? ಸ್ಕ್ರೀನ್ ಶೇರ್ ಆಗಿದೆ ಅಲ್ವಾ?
Yes, sir.
Okay, fine. So we will continue. So we were discussing factors responsible for temperature distribution and wind ಬಗ್ಗೆ ಅರ್ಥ ಆಯ್ತಾ? ಅಪ್ವೆಲ್ಲಿಂಗ್ ಡೌನ್ವೆಲ್ಲಿಂಗ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್. ಓಕೆ, ಲ್ಯಾಂಡ್ ಬ್ರಿಡ್ಜ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ? ಅಲ್ಲಿ ಅಪ್ವೆಲ್ಲಿಂಗ್ ಆಗುತ್ತೆ. ಸಿ ಬ್ರಿಡ್ಜ್ ಇರೋ ಪ್ಲೇಸಸ್ ಅಲ್ಲಿ ಡೌನ್ವೆಲ್ಲಿಂಗ್ ಆಗುತ್ತೆ. ಕರೆಕ್ಟಾ? ಜನರಲಿ. ಸೊ ಅಪ್ವೆಲ್ಲಿಂಗ್ ಆಗೋ ರೀಜನ್ಸ್ ಅಲ್ಲಿ ಟೆಂಪರೇಚರ್ ವಿಲ್ ಬಿ ಲೆಸ್. Downwelling regions where downwelling is the dominant process where temperature increases. Any doubt in this? Any doubt? Okay. So we'll also discuss. So you can see temperature of Atlantic Ocean is more than other oceans, right? In Pacific Ocean, temperature varies. For example, in oceans, if you consider northern part of any ocean, Atlantic or Pacific, say Pacific, where the temperature is bit lesser, right? And salinity also. Salinity we'll discuss salinity. Let's not mix it up. Okay. So we'll discuss horizontal and vertical distribution of temperature. So horizontal distribution means on the surface from lower latitudes to the higher latitudes. Okay. So consider this from equator towards poles, how the temperature varies. What you should know. So just understand it by a graph. Consider average. I'm taking around 27 degrees Celsius here or 25 degrees Celsius taking near equator. So what happens initially? Temperature increases because equator is not the highest. Equator doesn't have highest temperature, right? So initially temperature increases, right, up to subtropical region. After that temperature starts decreasing, right or wrong? So in the southern hemisphere also it will be same. So generally we can say temperature increases with increasing latitude, but except in this small section where highest temperature is not found on the equator but in the tropics or subtropical region. Correct? The reasons you understood why there is no highest temperature in the equator. Is everything ಅರ್ಥ ಆಗಿದೆ? ಕರೆಕ್ಟಾ? Any doubt here? Okay. We'll consider depth. What happens to the temperature with depth? So now take the depth from 0 meter to it's a mean sea level. We are going to the deeper parts. So the average would be 4. What is the average depth of oceans? Depth is still with average 4,500 meters. Correct? So oceans are in the range of 4 to 6 kilometers or 5 to 6 kilometers deep usually. I'm considering average 4.45 to 5,000 kilometers. So what happens to the increasing depth? Consider at equator we are considering temperature is 25 degrees Celsius. So what happens to temperature with increasing depth? So this is 20, 15, 10 like that. So how should I draw? This side or that side? This side. So observe this carefully, how I am drawing this. This is important to understand. So there can be 3 divisions. Number 1, there can be 3 thermal divisions in the oceans. First division, second division, and third division. What are you seeing as first division? More or less there is constant temperature around 25 up to 200 meters. Up to 200 meters. After this up to 1 kilometer, right? Up to 1 kilometer there is a transition zone. Beyond that the temperature is low here. So this is cold water. Correct? Because you can see temperature is nearly 0. Correct? And here there is a transition zone where there is rapid decrease in the temperature. And this is a zone, upper surface, where temperature is high. So high temperature zone, here it is a transition zone, and third one is cold water zone. 90% of water is in this region, in the oceans. This is only 10%. Correct? Understanding this? 90% is in deep sea, right? So this is cold water. So this is called transition zone, where temperature is rapidly decreasing. All of you know this. What is this called? This is called thermocline. What is this called? Thermocline. Thermocline. So thermocline is a region in the ocean at a certain depth where temperature decreases drastically. Correct? Understanding this? So this is a transition zone. After that, there is again more or less constant temperature, but temperature further decreases with the depth. But rate of decrease is less. Here, rate of decrease is very high. Rate of decrease is high. Suddenly, water is getting cooler here. Correct? After that, after certain point, temperature will be low, but the rate of decrease in temperature will be less. So these are three divisions. Understand this? Such three divisions are more prominent in tropical regions, because in tropical regions, upper part temperature is high. What about colder regions, Arctic region, for example? There, even at the surface, the temperature is less. Correct? Say 5 degrees Celsius or 10 degrees Celsius. So it will be like a single line. So there will be no three divisions. These three divisions are more prominent in tropical regions, because in the tropical regions, upper part is more hotter. Warmer water will be there. In colder regions, from here itself, there is cold water. Below also cold water. So what is the division you make? So as you go towards poles, the divisions would not be conspicuous. Understanding this? Huh? Sub-zero not. Sub-zero. And higher pressure will also be there. So, I mean, no, because of high pressure, it will not have. So similarly, salinity we can get. So you understood temperature distribution horizontally and vertically. Vertically means with respect to depth, right? Salinity. Salinity more or less will be the same factors. Tell me what are the factors which affect the salinity? Huh? Horizontal distribution of. Again, latitude will be a factor, right? Latitude will be a factor, because again, temperature is a factor which determines salinity. So wherever the water bodies, if they are hotter, the salinity is high. They're directly proportional. Salinity and temperature. For example, take example of Red Sea. Red Sea has more temperature. Just now I understood. So salinity is also high there. Take Baltic Sea. Baltic Sea low temperature. That's why salinity is also less. So they're related like this. So basically, there are two factors. What we call evaporation and precipitation. Evaporation and precipitation. Evaporation means, you know that water will transition from liquid water to gaseous water. It will evaporate, right? So rate of evaporation is high in the regions where temperature is higher. Warmer water are there, right? So if precipitation is higher, salinity decreases. Precipitation means mainly rainfall. Correct? Evaporation means loss of water. When water has been lost, what will remain? The salt content will remain. So that's why it increases the salinity. Correct? So you consider other factors would be supply of again fresh water, right? So you take example of India only. In India, the Bay of Bengal and Arabian Sea, to consider, more fresh water is draining into. You know that more than 70% of our drainage system is directed towards Bay of Bengal. More fresh water is entering into Bay of Bengal. So that's the salinity here. What happens? Decreases because fresh water is coming. So here, less number of rivers drain into Arabian Sea. That's why salinity is high. Correct? So supply of fresh water is also important. Take the example of equator region also. In equator, there is everyday rainfall. So that way, everyday fresh water supply is there. So that also decreases salinity there. Correct? Comparatively, it decreases. Right. Again, ocean currents. Ocean currents also contribute, right? If there is warm water, warm ocean currents, it will increase the salinity. Cold water, it decreases the salinity. Then wind also increases. For example, take the same example of Norway. This North Atlantic Drift or Gulf Stream. Just now I give an example, right? So this is taking warm water from here to here. Also, it is also it is carrying the saline water from here to here. In other words, so salinity here also increases because of the North Atlantic Drift, this ocean current. Correct? So same factors, more or less same factors would also contribute to the salinity. If you compare the different oceans of salinity, in terms of salinity, the Pacific Ocean salinity is ranging from 33 to 37 ppt. So what is ppt here? Parts per thousand. Okay. So it is written in this symbol. Okay. This is the unit of to measure. So for 1,000 volume of water, what is the amount of salt? So that is how we measure, right? So for Pacific, average salinity of the world is in this range actually. Okay, average salinity of world of ocean waters is in this range. So even if you take average from this, it will be 35 ppm. So in the exam, if they ask you what is the average salinity of the world ocean waters, it would be 35 ppt, or in the range of 33 ppt to 37 ppt. And this is also again average. Average of this will be 35, 33 to 70, 37. Okay. So Atlantic Ocean has high salinity. Atlantic Ocean has high salinity, and Pacific Ocean has lot of variations. Correct? You know, Pacific Ocean and Atlantic Oceans both have variations. Why? Because they extend from north to south completely. Correct? So northernmost will be near to Arctic, and they are also extended tropical region and equatorial region where salinity is high. And again, they are near to the Southern Ocean, so where temperature is less and salinity is also less. Understanding this? So, for example, take North Pacific. North Pacific has low salinity. The reason is it is close to Arctic region. Okay, fresh water from Arctic region mix up with the water bodies of Northern Pacific and Northern Atlantic. Are you understanding this? In Northern Pacific water, consider this is Northern Pacific, this is Arctic region. Fresh water from Arctic region will flow into Northern Pacific, and there it reduces the salinity. Same goes with the Atlantic Ocean. Okay. So salinity for Indian Ocean, this we have already discussed. Bay of Bengal and Arabian Sea, the difference. And Baltic Sea again, that's famous example. Their salinity is less. One reason is temperature is less. Another reason is it is supplied with a lot of many number of rivers. Correct? So you know the country called Finland that has so many rivers, all of them drain into Baltic Sea. That is why salinity there decreases. Correct? So you can take Baltic Sea also, right? Black Sea. Black Sea also, it is drained by many rivers. That's why they decrease the salinity. Correct? So consider these examples, go and revise them. So next we'll study movements of ocean waters. Ocean waters can move in three ways. Number one, waves. Number two, tides. Then we'll study currents. So these are the three important movements in the oceans. Correct? Ocean water move in the form of waves, or in the form of tides, or in the form of currents. Correct? So we'll take tides, waves first. Waves are generated by one answer should be waves are generated by wind, and they're affected by gravity. Remember it, wind and gravity. Remember these two factors. And one more factor in ocean waves, water is not traveling. Water is not traveling. It is only circulating at the same place. From there to here, when you see ocean wave is approaching you, actually water is not transferring from there to here. Only the energy is transferring. Okay, only the energy is transferring. How? I will explain it. See how the wind waves create. So there is a wind blowing. Correct? It's a vast sea. There are no disturbances. Correct? On the land there are ups and downs, right? But ocean mean sea level would be same, right? So there are no disturbance. So there will be high wind speed. This wind disturbs this area when it interacts with this. So what happens? Water level rises here. This like this. Correct? Because the wind hitting to the water. Right? So water here below water will be also rising like this. Correct? So next, once it has gone above, gravity acts. Correct? Gravity pulls it down. So it has fallen down. It has fallen down, right? Once it has fallen down, it is nudging the other water also. Here also it is forcing other water, right? So again, the next water will rise. Correct? Again, under gravity it will fall. The water will be here only. What is transferring here? The energy. This wave is putting energy onto the water which is adjacent to it. So again, the next wave is generating. So this is just an energy. But what about the water movement? Water first initially what is happening below water, it is rising, and again it is also falling, and it will again push this. Correct? So there is a circular movement below. So this question can be asked. What kind of movement will be there? Circular movement below. correct? And water is not getting displaced, energy is getting displaced under the forces of gravity, correct? The first energy is given by wind. After that, it is like relay of energy, correct? So once the water, this wave approaches ocean coastline, so there is this continental slope and shelf. Here you are, for example, this is the mean sea level. So I mean, yeah, I mean it should be at the surface actually. I should take it this way. Okay. So wave is traveling and approaching towards you, right? Once the wave comes near to the coast, what is happening to the depth? Depth is decreasing, correct? Because it is approaching continental slope region and shelf region. So depth is decreasing. Once the depth decreases, so that this is the what wavelength, correct? And what is this? This is the depth. This is the depth, and this is the wavelength. If the depth is half of the wavelength, if the depth is half of the wavelength, the wave breaks. The wave breaks, and it will create this surf. Here, where people go for surfing, that's called surf. That's all. So these are the important things that you should remember. Mainly this section, how it is generating. That's more important. And one more point: there is no actual transfer of water; it's only transfer of energy, and there is a circular movement below. These are the few points. Next, with respect to tides, come to the tides. What is tide? Tide is a vertical movement. Basically, it's a vertical movement, right? Tides are generated by what forces? By the gravitational pull of sun and moon. Remember it. Where the gravitational influence of moon is more. Why?
It's more closer.
It is more closer. What is the distance between Earth and moon? 3.84 lakhs. This is the average kilometer. 3.84 lakh kilometers. Correct? Lakh kilometers. This is the average distance. And moon is also revolving around Earth in an elliptical orbit. So sometimes it comes very close to the Earth. Sometimes it is away from the Earth. When moon comes nearest to the Earth, that point is called perigee. Perigee. Like perihelion, you understood, right? For sun. So perigee means moon. Next, apogee. Like just like application, farthest point. Okay. So it will be farthest will be around 4,05,000 kilometers, 4.5, and nearest should be around 4.6 lakhs kilometers. Okay, so average would be 3.84. Okay, so this is the distance. And distance between Earth and Sun, you already know that's 150 million kilometers. That's 15 crore. 15 crore. So that's why the influence of moon is more on water bodies. Correct? So it is like ocean, right? Ocean water. Yeah. Let us take from this side. So this would be water body, correct? So there is a moon here. Okay. So gravitation pull of moon is attracting this water. Correct? The water is trying to reach the moon. Water is trying to reach the moon, but it can displace only up to this extent. It cannot reach till here, right? So it's like attraction. Correct? So that's why what happens when moon is also not on the same side, because Earth is rotating. Basically, Earth is rotating along with the moon is also rotating. So we'll consider that moon is fixed. Moon is fixed and Earth is rotating. Moon is fixed, Earth is rotating. Correct? From west to east. So what happens? Currently, this region is facing the moon. Correct? So now the gravitational pull will be more here. Correct? So that's why you can see water level will rise here. Correct? Water level will rise. All of you have completed this, right? This is just a revision class. That's why I'm going quick. So what is happening here? There is increase in the water level. Correct? So this is called high tide. Okay. What about this side? It is facing away from the moon, right? So here, because water level has come here, risen here, there will be less water available here. So water level will decrease here. So this is low tide. Again, this will be low tide region. But again, there will be high tide. What is the reason that there is high tide on the opposite side? Huh? Magnetica. Not magnetic. Centrifugal force. Centrifugal force. Centrifugal force. So what is centrifugal force? Any body when it rotates, there are two forces. One is acting towards the center, one is away from the center. The force which is away from the center here is centrifugal force. Why centrifugal force is dominant over here. See, centrifugal force exists everywhere, but it is more dominant here because it is this region is facing away from the moon. So here influence of gravity is not there. In other places there is influence of gravity which cancels out the centrifugal force. But this side there is no gravitational force. The influence of gravity is not there. Now centrifugal force is excessive and it is free to apply completely. So that's why there is high tide again. So the side which is facing the moon currently and the side which is facing away from the sun, both these sides receive high tides. Correct? So these 90-degree angle regions they receive low tides. Correct? Either sides will receive low tides. Correct? So low tide, any region, every region in the world, for example, take Indian coast also. Like if you go to Arabian Sea, if you go to Mangalore or some regions, coast region, every day there is a high tide when this region is facing the moon. And when Earth goes away from the moon, there will be again low tide. Correct? So it will be like this. So high tide, water level will rise. Correct? So there is a beach. Okay. Initially, you assume you are standing here, right? So water level has reached lowest point because now it is on the at the 90-degree side of the moon to the moon, right? That's why water level has come down. So this is low tide line. What is this called? Low tide line. When this region is facing moon, then water level will rise. Now water level will come here, here. What is this line called? High tide line. Correct? So what happened here? As this region has approached moon, water level has from here to here it moved. Correct? Water level has moved from low tide line to high tide line. So the movement of water from low tide line to high tide line is called flow. It is called flow or flood, whatever it is. Flow or flood. Correct? So here they have given flow or flood. Which word they have given? In NCERT? Do you have book? Okay, whatever. Flow or flood, both would be fine. Okay. So when after some time, what happens? Earth will go away from the moon, right? So same surface will not be facing moon all the time. So now, flow or flood, yes. So once the moon moves away from, once the Earth moves away from the moon, this part, what happens? Water level will again move from high tide to low tide. Correct? So water level will move from high tide to low tide. So this is called ebb. Remember. So flood and ebb. Flood means movement of water from low tide line to high tide line. It's rising. Water level is rising. Flood means water level rising from low tide. Movement is from low tide to high tide. When movement is from high tide to low tide, when water is receding back, that is called ebb. So every time this is happening, correct? Currently it is happening. Either water is moving from low tide to high tide or high tide to low tide. So every minute, every moment, it will shift from one place to from here to here, or either from here to here. Understand this? So flood and ebb movements are everyday processes. So, and this region is called intertidal zone. What is this called? Intertidal zone. This is the place where our mangroves are located. Intertidal zone. Sundarban forest and all, deltas and all of them are located here. Intertidal zone. Next, there are few more things you should understand: spring tide and neap tide. So don't get confused here. Spring tide means we can take only high tide as criterion to decide whether it's a spring tide or neap tide. Let's not consider low tide at all. Only consider high tide. If the high tide on a particular day is higher than usual, correct? Usually high tide will be here, but on a particular day, what is happening? High tide has come till here. So your high tide is higher than usual. So such tides are called spring tides. If the high tide, instead of being here, if the high tide has come here, this is the maximum line that the high tide can reach on a particular day. Usually it used to reach here, right? But on that day it is less than average. So that is called neap tide. Understand this? So what is neap tide? High tide is lower than usual. Spring tide, high tide is higher. Spring tide, high tide is higher than usual. Understanding this? Okay. What is the reason? Sometimes only few days, only sometimes this will happen. What is the reason when there will be spring tide? There should be higher force, right? There should be higher attraction by moon or sun. Then only the water level will rise. So that will happen when sun is here and moon is here, and sorry, when earth is here, moon is here, and sun is also here. So both are in the same line. Correct? So both are more or less in the same line. Then what happens? Both of energy in the water and attract ಮಾಡ್ತಿದ್ದಾರೆ. So what happens? The water level will rise more. High tide will be higher than the usual, and contrarily, low tide will be lower than usual. That you can guess. High tide is higher, more water has come this side. So this side water level will decrease. Understand this? So what is the time difference between high tide and low tide? On a particular place, you go any beach, currently there is high tide. For next low tide, how much time? 7 days. Days. Every day there is high tide and there is low tide. Every day 2 times low tide, 2 times. So you haven't understood. Listen here. So consider this region we are considering. This is the region we are considering. Currently there is high tide. Okay. There is a moon here. Moon is fixed. We are assuming moon is fixed. Now earth is rotating in any way. Earth is rotating this way. Okay. So now this place has come to this region because earth is rotated. Correct? Earth rotates in 24 hours 360 degrees. So this is quarter of it. That means 6 hours, right? 6 hours, 12 hours, 18 hours, 24 hours. Same place to come back to the same position to face the moon, it will take 24 hours. So should be 6 hours. Correct? Again, another 6 hours it will be facing again. This region, same region has come here. But this time again, when it faces opposite side of the moon, there will be, due to centrifugal force, there will be high tide again. So time difference between two high tide should be 12 hours. So here time difference between high tide and low tide should be 6 hours. Again, 18 hours low tide. Another 24 hours again high tide. But this is what you understood. There is a little variation here that you should understand. What happened here is, listen carefully. This is earth and this is moon. This place. So what you know is, from here to here, the same place, when it has to come to the same position, how much time it takes? 24 hours. That's your understanding. But what is happening here is, in one day, our moon is also shifting from here to here. Because moon has to complete one revolution in 28 days. Correct? So moon has to shift from here, right? He cannot be still. He is also revolving. So moon position also shifts from here to here in one day. Correct? Now, moon is not here. It has come back to the same position. But it is looking for moon. Moon is not. Moon is here. So high tide would not occur. Correct? What should happen? Assume moon has come this. We have taken reverse example. So extra moon has come from here to here. Right? Now, to face the moon, this place has to rotate for another few hours or few minutes. Then it will be facing the moon. Then it will receive high tide. So this extra minutes is 50 minutes. So total revolution, this is called lunar day. What is this called? Lunar day. Solar day is 24 hours. Lunar day is 24 hours, 50 minutes. So now divide it by 4. That will be the case. That's 12.5, right? Divided by 4. 50 divided by 4 is 12.5. So time difference between high tide and low tide is 6 hours, 12.5 minutes. Time difference between two high tides is 12 hours, 50 minutes. Correct? Sorry, 25 minutes. 25 minutes. Okay. Understood. Next, time difference between next low tide will be 18 hours. Again 37.5. Again, for another high tide, it will be exactly 24 hours, 15 minutes. I've understood this concept. All of you have understood what is spring tide and low tide? Everybody? Okay. Spring tide is when sun, moon, and earth are more or less in the same line. Then the gravitational pull of moon is supplemented by sun also. So high tides will be higher than usual. So this is what we have discussed about tides. But one more concept that has been remained here is that usually what happens in every place, there is high tide in every place of the world. Generally, okay. So there is a high tide and there is a low tide in a day. After this is in 6.6 hours, 6 hours, 12.5 minutes. There is after 6.6 hours, 12.5 minutes, there will be a low tide. Correct? Again, after 6 hours, 12.5 minutes, there will be another high tide. Again, there will be another low tide. In total, 24 hours, 15 minutes. Understand this? So, generally, in any place, there are two high tides and two low tides. And also look at the height of the high tides. They are same here, and height of the low tides will be same. So this will be usual. Such kind of cycle is called semi-diurnal. Semi-diurnal cycle. Semi-diurnal cycle of the tides. But in few cases, what happens is there will be a high tide. There will be again a low tide. But next high tide will be lower than the first high tide, or it can be higher than the low tide, but it is varying. Correct? In this case, it's varying. And low tide will be lower than this place, lower than this low tide in a day. So this is a cycle of one day. In one day, there are two high tides here and two low tides, but both of them are equal in heights. So such tides are called semi-diurnal. Such cycle is called semi-diurnal cycle. Correct? And here they is called mixed tides. What do we call them? Mixed tide cycle. Mixed tide cycle. Mixed tide cycle means at any place if there is a mixed tides are there. There will be two high tides, two low tides, but the heights of high tide and the heights of low tides will be varying. Understood this? Remember this. So in India, this coast, what is this coast? Eastern coast, facing Bay of Bengal. Bay of Bengal coast has semi-diurnal. Remember it, semi-diurnal. So if you go to this place, there will be two high tides and two low tides in a day. Okay, and both of them will be of equal heights. And in Arabian Sea, there are mixed tides. Correct? Mixed tides means there are two high tides and two low tides, and but the height is different. Okay, the reason here it is very complex. It depends upon the shape of the coastline. Okay, shape of the coastline or the distribution of land and water. Okay, and how effectively it can be facing the moon. So there it's a very complex, many complex factors to determine. But there is another type of cycle here with respect to tides that will be in a place like, for example, Gulf of Mexico. Remember this place, Gulf of Mexico. There you will find only one high tide and one low tide. That's all in one day. Usually in other places we find two high tides and two low tides. Again, it depends upon the shape of the Gulf itself. Okay. So these tides are called diurnal. What they are called? Diurnal. So diurnal tides, semi-diurnal tides, mixed tides. Correct? Semi-diurnal is the usual one. Mixed tide is second usual, and this is the rarest. So we have completed physical geography. We will go to currents. Currents on the two aita. Okay, currents. Currents again. So currents ಹೆಂಗ್ ಒರಿಜಿನೇಟ್ ಆಗುತ್ತೆ? Currents ಹೆಂಗ್ ಒರಿಜಿನೇಟ್ ಆಗುತ್ತೆ? Fast. Main reason is difference in the insolation level. Right? Earth does not receive insolation equally in all places because of the tilting and the shape. Correct? Correct or wrong? Okay. So equatorial region, that is tropical regions, receive higher temperature, higher insolation. Right or wrong? Okay. So assume this is equatorial region that or tropical region, and this is the polar region. So your temperature is high. That's why water level rises. What happens when temperature is high? Water level is bit higher because it expands. Water expands. When you heat up, it expands. Correct. So there is water level higher. Here, more denser. Correct. Cold water is there. Cold water is dense. It does not expand. It will condense. So here water level is less at this level. So what happens if slope has generated here, right? Correct. Along the slope, water moves towards pole. This is how ocean currents. This is the main driving force for. Ocean current. This is one reason. Another reason for ocean current generation is waves again. waves. Okay, first one is what? Differential heating of earth, that is insolation. Okay, second is waves. Another reason could be the factors which influence is the shape of the continent. Shape of the continent, right? Because they move along the continents. As the shape of the continent, the direction will be such. And Coriolis force also influences. Correct? So, and density also is a factor. Density is also a factor because more dense water sinks down. In cooler regions, dense water sinks. Correct? This create deficiency here. The water from here it will, from here to here it will. Why? Because water here has seen deficiency. So this is another driving force. Here density is the factor. That higher density is leading to the sinking of cold water. Correct? So these are the factors. So you know the factors which are responsible for the origin of currents. Now you have to see the actual currents of the world, and there are two types of currents: surface currents and deep water currents. Okay, so we will study only surface current, but also understand that there are more number of deep water currents. Okay, surface current means, for example, consider the same example here: water in Arctic region or polar region is sinking down, right? It is creating deficiency of water here. That is why to fill that water is displacing from here to here. Correct? So this is generating a current. Correct? Now we can see what is happening. Once the water is displacing here deficiency is creating, right? Actually, what is happening is there is a driving force which will make this deep water to travel back towards equator. Okay. So on the surface, water is displacing from equator to poles, but below which, under water, the water is flowing from poles to the equator. So this is what? Deep water currents. So there are two types of currents. Okay, and same water will reach here and it will come back. This is the cycle. This is the larger picture. This is the larger picture, okay, of how ocean currents are generally moving throughout the world. Now we will study surface currents only. Okay, we have to remember the names of surface currents because there are no specific names for deep water currents. So what you have to study? Surface currents only. So take ocean by ocean. First take Pacific Ocean. Pacific Ocean, you know, this is what? Asia, that is Russia and China and all. This is North America, correct? And this is equator. There is Australia below this, right? So along the equator, there is, already know that this is north equatorial current, which is warm, correct? Because temperature is higher, this is warm current. It is flowing from here to here, right? So once it hits the landmass here, it will diverge to the north. There is Japan here, correct? Have you completed? All of you have completed currents? ಗೊತ್ತಿದ್ಯಾ? ಫಸ್ಟ್ ಟೈಮ್ ಯಾರು ಕೇಳ್ತಿದ್ದೀರಾ? ಫಸ್ಟ್ ಟೈಮ್ ಯಾರು ಕೇಳ್ತಿದ್ದೀರಾ? ಯಾರು ಕೇಳ್ತಿಲ್ಲ ತಾನೆ? Fine. Yeah. So all of you know this. Tell me what is this? Which current is? What is the name of this current? Kuroshio. So Kuroshio is warm current or cold current? They will ask this. It's a warm current. Now, this is North Pacific current. North Pacific current. It will come back, right? So while coming back, you know, this water here is colder. So what is the name of this current? Allah. California current. In US and California is there. So this is California current. Again, same California current will become equatorial current, north equatorial current. So it will. This is called gyre. What is this called? Gyre. So why it is moving this way here? Because of the shape of the continent. And again, westerlies here. Westerly winds. Winds are also responsible. And Coriolis force. Coriolis force is acting rightwards in the northern hemisphere. All of you know that. So Coriolis force is also responsible. Wind is also responsible. Shape of the continent is also responsible. You just have to remember these facts. North equatorial, Kuroshio, North Pacific, California. California is cold. California is cold current. Just remember this. But just like North Atlantic drift that you understand Atlantic Ocean, here warm water will be carried by westerlies to Alaska. So this is warm water again. Alaskan current is, even though it's located higher latitude, here also it is warm water. So this is what? Warm water. This is Alaska region of USA. So here whatever the water current is there, it is also called Alaskan current. So it also, because of the shape of the continent, it deflects towards left and same water will come back. Correct? While coming back, it is it will meet this cold water coming from Arctic. So remember, there is another cold water coming from Arctic region. This is called Oyasho. What is this called? Oyasho. Warm water coming from equatorial region is called Kuroshio. Cold water coming from Arctic region is called Oyasho. This is Kuroshio and this is Oyasho. Both of them meet here. Kuroshio and Oyasho meet near Japan. Okay, so remember it. And this is Alaskan current. It will also be joined by this. Correct? So you can say two cycles are forming here. One cycle is here. Tell me, repeat, come with, say with me. North equatorial current, Kuroshio current, North Pacific current, California current. Can you see a cycle here? This is called gyre. Gyre. Main reason for gyre formation is Coriolis force. It is clockwise. They will ask you the direction. North Pacific gyre is clockwise in direction. The reason is Coriolis force. It acts rightwards. Right. This is a gyre. There is another small gyre is forming here. Correct? Two gyres are there in North Pacific. So this is North Pacific. This is Alaskan current, warm current. Then Oyasho current is cold current. Correct? So this is another gyre. This is Alaskan gyre, you can say, not second gyre, right? Small gyre. It's correct. So here you can see what Oyasho and Kuroshio are meeting. Whenever warm water and cold water meet, this is warm water, this is cold water. Kuroshio is warm water, Oyasho is cold water. When they meet near the coast of Africa, whenever warm water and cold water meet, that is a good fishing zone. Because warm water is good for the growth of multiplication of planktons. Correct? More number of planktons will be producing over there. And cold water brings nutrition. Cold water is rich in nutrition. So that is why more number of planktons will grow here. More number of planktons are growing. To eat planktons, fishes are coming there. Correct? So that's why there is a good fishing zone here. Understand this? Because of plankton growth. Why plankton growth is there? Because of better environment, better conditions there. Like warm conditions for multiplication of planktons and cold conditions brings nutrition. Understanding this? Here again, South America, correct? It will South equatorial current and it will hit the coast of Australia and it will come. And always remember, in southern oceans, always there is one current that is flowing. This is called west wind drift, or Atlantic circumpolar current, Atlantic circumpolar current, or WWD. So in Atlantic Ocean also this will be there in the southern sections. What is this current? West wind drift. So we'll meet for Indian geography at 3. So we can look for other currents, or shall I again complete it? Same thing will be there in every ocean, but in Indian Ocean there is a reversal. Why there is reversal in Indian Ocean? Anybody? Complete my bit. 5 ನಿಮಿಷ.
ಸರ್ ಎಲ್ಲಿನೋ ಲಾನಿನೋ ಮಾಡ್ತೀರಾ?
ಮಾನ್ಸೂನ್ ಜೊತೆ ಮಾಡ್ತೀವಿ. ಮಾನ್ಸೂನ್, ಇಂಡಿಯನ್ ಮಾನ್ಸೂನ್. ಇದು ಕಾಣಿಸ್ತಿದೆ ಇದು ಸ್ಕ್ರೀನ್ ಇವಾಗ?
Yes, sir.
Okay, ಇದು we were discussing this Australia, South America, and so this is South equatorial current. This is Australian current, East Australian current. See here, you can guess it. This is north. This is warm current, right? Always near the equator there is warm current. Same warm water is coming to the south, so it should be warm current. East Australian current should be warm current. But once it meets this west wind drift, this is cold current. West wind drift is cold current. It will become cold current here. What is this? WWD. And it hits the coast of southern tip of South America. It will diverge towards this continent. Here it will be cold current, right? Because cold current is deflecting. Cold current. This is called Peru current or Humboldt current. What is this called? Humboldt current. What is this called? Humboldt. Humboldt current is what? Cold current or warm current? Cold current. Because WWD itself is diverse. Again, it is South equatorial. This is warm current, and warm current will diverse into East Australian current. That's also warm current. And WWD cold current. Humboldt current is also called Peru current. So this is another gyre here, right? What is this gyre? In which direction it is? Anti-clockwise. This South Pacific is anti-clockwise gyre. Correct? Because here Coriolis force is acting leftwards. Next, come to Atlantic Ocean. Atlantic Ocean, we take continents of North America and North Atlantic. Correct? So this is Gulf of Mexico. This is Brazil here. North South America, Brazil. Okay. So what happens here? Warm current is coming here. What is this? North equatorial current. It's heading to the coast of Brazil. So it will deflect towards north. It will go to the Gulf of Mexico. From where it is called Gulf Stream. Correct? Or else here Caribbean current ಅಂತ ಕೂಡ ಕರೀತಾರೆ. Caribbean islands ಇದೆ. Antilles current ಅಂತ ಕೂಡ ಕರೀತಾರೆ because Antilles islands ಇದೆ. Correct? Name based on the island they are called. And what happens here? This Gulf current, because it's coming from Gulf of Mexico, then same Gulf current will drift towards Europe. This is drifting. You already had an example. Norway hoಗುತ್ತೆ ಒಂದು current ಅಂತ same. That's warm water. This is North Atlantic drift. North Atlantic drift. Why it is drifting like this? Because of westerlies. Influence westerlies are more stronger here. You know, westerlies winds, they carry warm water from here to here. So that is why warm water can be seen in Norwegian coast also. Correct? Even though it is located near the polar circle. Understanding this? So complete the cycle. So part of it will come back. I mean, not like this. Yeah, part of it will come back. While coming back, we can see this will be cold current. Here there is Africa also. Here there is Africa. Correct? Yeah. What is this called? Canary current. Because of Canary Island. Canary current. And it will be deflected like this. What is this? North equatorial current. North equatorial current, Gulf Stream, North Atlantic drift. No, drift will be that side. Gulf Stream, then Canary current, and this one gyre has been forming, right? Correct? So this is clockwise again. And one more point here is, just like we have seen Kuroshio Oishio meet to create good fishing ground. Here also Gulf Stream is met by Labrador current here. There is Greenland here. West of Greenland, there is one current coming. That is Labrador current. Gulf Stream and Labrador are meeting at this place, Newfoundland of Canada. That's also good fishing zone. This is called Grand Tank or Grand Tank. Grand Tank. So there are two zones here. Here also good fishing zone is there. Okay. So this is Dogger Bank. I'm just confused which one is Dogger and which one is Grand. This should be Grand Tank. This is Grand Tank and this is Dogger Bank. Because of they are called fishing zones. Okay. So in the world, wherever there are warm water and cold water mixing, they are good fishing zones. Okay. Come to South Pacific. Come to South Pacific quick. So this is South America and this is Africa. Correct? Africa. Equator. South equatorial current hitting to the coast of Brazil. What is this called? Brazil current. Warm current. Of course, equatorial current will deflect. It's a warm current. Again, which current is there? WWD. Correct? I already told you. This is same. So it's cold current. And this WWD hitting to the coast of Africa. This current is cold current. West coast of Africa. That's what? Benguela current. Benguela current. Okay. So it is becoming warm current again. Correct? Anti-clockwise gyre is formed. And one more point here is, just remember there is an island called Falkland Island here, which is disputed between UK and Argentina. Falkland Island. This island is disputed between Argentina and UK. This is UK colony. Okay. So here what is happening is Brazil current is approaching this, right? And this WW is coming from here. Correct? This WWD, that is west wind drift, takes little deviation here also. After hitting to the coast of this Falkland. So here also they meet. Brazil current and this is called Falkland current. They meet. So this will create another fishing zone because it's a warm current and this Falkland current is cold current. Correct? There's another fishing zone. So come to Indian Ocean. Indian Ocean is half ocean, right? South Indian Ocean will finish. South Indian Ocean will. So this is Africa again. Correct? Equator. What happens here? This is warm current, south equatorial current. This is called. There are two names to it. There is one country, an island country here. What is this? Mozambique. Correct? So because of that, no, there are some islands. This is called Mozambique current, and it's also called Agulhas current. Actually, this divides like this because of some islands. So that's why they are called Agulhas, and in NCERT they have given Agulhas or Mozambique. Only one name they have given. So remember Agulhas, that's enough. Or it can also be called Mozambique current. So it's a warm current basically. West side of Africa there is Benguela current. East side there is Agulhas current. So it is met by again west wind drift, cold current. Correct? Go till the coast of Australia. When you hit to the coast of Australia WWD, it will become West Australian current. It is cold current. And this is South Equatorial current. This is Agulhas current. WWD. This is one gyre. Correct? So come to North India, North Indian Ocean. North Indian Ocean, here at the center there is India. Correct? And here ocean is not there. This is a half ocean, right? And this is what? Africa, correct? See here, this is a special case. This is North Indian Ocean, Bay of Bengal and Arabian Sea. Here the ocean currents are entirely influenced by winds. Entirely influenced by winds. You know monsoon. Monsoon ಬಗ್ಗೆ ಗೊತ್ತಲ್ವಾ? So in monsoon there are two types of monsoons. Southwest monsoon, because when ITZ shifts to north, southwest monsoon sets in. When ITZ shifts south, northeast monsoon sets in. Right? So in one season the winds will be blowing from here to here. Correct? So that's the ocean current direction will be like this. This will be the direction. Correct? Understand this? So this is North Equatorial. When monsoon winds, southwest monsoon winds are there. When winds are blowing this way. Correct? So what happens? In northeast monsoon, what happens? In northeast monsoon, winds will be blowing from land to sea. This way. Northeast side. So that's why direction will change. This is which direction? Anti-clockwise. Earlier, clockwise. So there is a seasonal reversal in the currents movement also. Equatorial current and all of this is called Indian current. Okay? Understand? North Indian current. So there is a seasonal reversal in the ocean currents in the North Indian Ocean. So we have completed physical geography. We'll start with Indian geography at 3 o'clock. 3 to 5, we need at least 2 hours. So what happened? So we'll meet at 2:45. Half an hour at least needed for lunch. So we can continue. I have energy. Yes, na? 2:45 will meet. So will you be available? I mean, will you be sitting till 5 o'clock? Because Indian geography at least requires 1.5 hours and 30 minutes. I can describe something about Karnataka geography. Parallel. So we'll try. So we'll meet at what time? Tell me. 2:45. Okay, 2:50. We'll meet at 2:50. No problem. Come at 2:50, okay? See, Karnataka geography is more about facts. You can read it, right? At least we'll cover Indian, okay? Karnataka geography, ತುಂಬಾ ಜನ ಕ್ಲಾಸ್ ಅಟೆಂಡ್ ಮಾಡಿದೀರಾ, and others, it's more about just facts, rivers, tributaries, ಅಷ್ಟೇ, ಏನು ಹೇಳೋದೇನಿಲ್ಲ, ಕಾನ್ಸೆಪ್ಟ್ ಇಲ್ಲ. Indian geography, somewhat I can explain, right? Karnataka physical geography, I will explain. Like physical divisions and all explain. Factual content like rivers, soil types also I will do. Like in you resources ಇದೆ ಅಲ್ವಾ, which mining is there in which district, ಅದೆಲ್ಲ ನೋಡ್ಕೊಳ್ಳಿ. Okay. Human geography